Welcome to the show. My name is Bret, and you're here on YouTube Live because you know that. That's where you're at. And we're talking today on all things DevOps, Docker. We're focused on DockerCon. I have some great guests coming up. But first, if you're new to this show, let me explain to you a couple of the things. Housekeeping, right? Basically, this is broadcast on 2 different streams on YouTube right now because Docker's stream is hosting me and the whole crew of Docker captains on the show for us getting ready for DockerCon next week, which is just days away in San Francisco. It's Docker's annual event. It's the leading conference. It's the very first conference, actually, 6 years ago on containers and the Docker ecosystem. And now it's just like a thing it's a track on every conference now. But DockerCon's still the OG awesome conference to be at. It's so much fun. We're all looking forward to being there. A couple of things. If you have questions, we're going to save those to later in the show. We're going to get through some discussions on recent announcements and stuff coming up at DockerCon. So if you have questions, get those into chat now. We're taking questions on, obviously, Docker, anything containers, Kubernetes, you name it. We're here to help, and hopefully we'll have all the right answers for you later in the show. And if you haven't the ability to watch this show, or if it's not even live, you know that this show stays up on the internet after we're live, basically is what I'm saying. On my YouTube channel at bretfisher.com/YouTube, you can actually subscribe and see this show every week. We're live almost every Thursday, and you can come hang out with us, talk containers, do some learning, hopefully teach us something that you're showing off that you've done with containers recently, and be a part of the show. It's a lot of fun every week, and I hope you'll come back to join us next time. We'll be live at YouTube next week. We'll be not live at YouTube. We're live at DockerCon next week on this YouTube channel. And first thing I want to announce is my new course that dropped today. So Docker for Node.js is here, and you've probably been hearing me talk about it for months. But finally, I launched it this morning. The whole team put in a huge effort on this. We've been working on this course for 6 months, so I hope if you have any interest in Node.js and using containers, you'll check it out. I think it's the best resource on the internet to take Node.js up to 11, is what I'm saying. That's an old movie reference in case you're not aware of that one. It's not going to 10, it's going to 11 because it's the best course, I think, for taking your Node.js, putting it into containers, making the best dev environment possible, testing, security scanning of Node, putting it into production, zero downtime, rolling updates, all that stuff's in there. So I hope you'll check it out at bretfisher.com/node. All right, coming to the show, I've got 2 other Docker captains this week. Drum roll. Drum roll. Got to click a lot of buttons. All right, welcome to the show, guys. First on the call, I have, this is a call, right? This is a conference call? No, it's not. It's the internet. It's a show.
That's
first
right.
First on the show, I got Nirmal Mehta from Booz Allen. He is the Chief Technologist at Booz Allen Hamilton, one of the Chief Technologists at Booz Allen. He is a Docker captain since April 2016. He's been using Docker since 2014 in various projects over the years. He's old school Docker. He's currently supporting Booz Allen's digital R&D emerging tech efforts, and he's on the show from Durham, North Carolina, just a few hours from me. Welcome to the show.
Thank you, Bret. Pleasure to be here.
Glad to have you. And you've seen him before on this show. Michael Irwin is back. He's the application architect at Virginia Tech. I'm sure there's more than a few of them, but he is a application architect and also the adjunct faculty instructor for Docker. No, I'm just making that up. He's just a regular adjunct faculty instructor and an awesome person in the computer science department at Virginia Tech. Thanks so much for coming to the show again, Michael.
Sure, have me again.
Yeah, I guess we didn't scare you off, so that's a good thing. That's a good thing. So we have lots to talk about this week, lots to unpack even before the show next week at DockerCon. We're going to, I'm sure, hear more announcements about this, but I know it's a topic on all of our minds because we've been talking about it for days now, is the announcement of Docker and ARM partnership and what that really means. So in case you're new to this or you haven't been checking the container news over the last, 24 hours, ARM and Docker dual announced a partnership. I guess that's how you'd say it. They both announced a partnership about Basically, Docker solving one of the bigger problems for the ARM ecosystem. Now, if you're not familiar, ARM is those chips on all the mobile devices, all the Internet of Things, embedded devices. You probably have ARM chips all over your house and you don't even know it, or maybe you do. And they're basically everywhere, and they are small and tiny little things that are really important in our lives. But one of the hardest things with ARM is still to have a good development experience and to have an easy development ARM, because it's a different processor, it's a different architecture type, so you can't necessarily just run it anywhere. So we're going to talk about this in a little bit. There's some other things I want to just show you real quick, in case you didn't know. So this is the Node course, and let me just tell you, having custom art is like, we all need a digital artist in our lives, is what I'm saying.
It's very cute.
Yeah, this is Foxy. That's the name we've given her, because she's a fox. And I'm now the new gold standard for anything you put on the internet is you gotta draw a character.
Nice.
We have a Docker captain that does some drawing in there.
I'm surprised the character wasn't whiskey.
Yeah, we thought about that, and then it was like, well, as whiskey because when we first started the course, it was way before whiskey, right? So we technically had Foxy months before we had a puppy. But yeah, so I'm super excited to have a mascot in the course, and you'll be seeing her showing up. She actually does stuff in there. She shows up when there's assignments and other cool stuff. So I'm super excited this is out, because it's perfect timing to talk about ARM, because Node.js is one of the sort of sweet spots on ARM. My understanding is, since Chrome, the V8 engine is where Node got its start. It was designed for the Chrome V8 engine, JavaScript, and that was designed by Google in large part for ARM, right, because of their mobile platform. So it kind of clicked with me yesterday that, hey, I'm just happen to be releasing a course related to this.
Just happen to be on it.
Just
It looks like some of your awesome students are already clearing a path through your new course already.
Yeah, I'm seeing that in the comments already.
Yeah, I think I've been hyping it up for a while now, so hopefully it lives up to the expectation.
I'm sure
I'm glad they didn't fall off in the long hype tail there. So.
That's right. That's right. I think someone said. I think someone in the YouTube said last night. Soon is finally here, because for months I've been saying soon, and they're like, I don't think that word means what you think it means.
So instead of Elon time, it's Bret time.
That's right. That's right. Months equal hours. It's actually code. I'm speaking in code. I'm actually a container spy, and when I say soon, I'm actually talking on the internet in terms of months. So.
I'm very happy for you, Bret and team. It's a big achievement. It takes a lot of effort. I know you showed me some of the behind the scenes of how much work and love you put into putting the course together, and I'm sure people will appreciate all the knowledge that you send out there.
Yeah, well, and you guys too. That's kind of how we got to be captains, right? Like we blogged on the internet, we talk at conferences. I mean, I think we're all we've been captains for a while now, and in case you didn't know, the way that Docker sort of nominates captains, it's a little bit like the Microsoft MVP program, where you have to be an advocate of the technology and talking and sharing all the things you know for a while on a consistent basis, and then you start to get noticed. And of course, you can always try to bug people at Docker, and but there is no technical application process, because it's more about just being a community volunteer, trying to help others, and then hopefully you'll get noticed and become a Docker captain. But they have a community leadership program, in case you're interested, that I always try to talk about, because I think it's the more important job in the community, which is running meetups and helping in your local community, whether that's at local conferences or talking at other meetups about container stuff. Docker has a whole program for that called, and the title, we actually get our own mascot. It's a dolphin, right?
Yeah.
We get our own swag at the conference, so that's a really neat thing. And that's pretty rare. Not a lot of companies will add extra content, like an extra half a day on the beginning of the conference, just for people that have meetups and that teaches us all the sort of responsibilities of being a community leader and gives us better skills on leading, because meetups are hard. They're deceptively hard if you ever run one. Getting good speakers, getting just good food on a consistent basis is a hard thing.
Can I just do it?
It's the dolphin, but the dolphin's juggling like food and
That's
a
right.
microphone and a laptop,
Pizza,
and all these things in the air.
Just a shout out to the Raleigh area. I've fallen a little bit in terms of scheduling the Docker meetups in the Triangle area. I promise on this YouTube live channel to pick it back up a little bit, pick up the pace.
Oh man!
That being said, though, our Triangle DevOps meetup, which is kind of the largest meetup group in the Triangle area, is rocking and rolling, and I'm also involved with that and the DevOps Days conference. So it's not like I'm completely missing the ball, but I do promise to kind of pick up the pace on the Docker Raleigh area.
All right, well, you heard it here on the internet. It's no big deal because he promised on the internet forever, so it's going to have to happen.
It's tough though. Yeah, it's no lie. It's tough.
Yeah, especially when it's zero money, right? Like when you have a family and you have a life, it's tough to make those kind of things happen. Those are the unsung heroes, I think, of open source, really. I mean, obviously, this is not just open source, but the community of tech is one of constant learning. And I have a friend who's been running his .NET meetup for over a decade. And they're the largest meetup in our area, and he was doing .NET and he actually, they've had people rotate in and out, but he's always overseen it, and it's an amazing body of work that, you know, it's not like there's a bunch of videos on the internet that show effort. It's just showing up. It's like being on city council or something. It's like, you know, all you hear is, you don't hear a lot of praise. You usually just hear the complaints or the suggestions.
Yeah.
So let's talk about this Docker ARM thing. Nirmal, what's your take?
I think it's a great move on both companies' parts. I think it's a good move for the community in general. ARM and the acceleration of IoT and non-x86 chipsets, especially as it goes to more of infrastructure server roles, has been accelerating tremendously in the last, I would say, 5 years. You know, oftentimes as technologists and hobbyists and smart home hackers, we usually touch ARM in the Raspberry Pi kind of world, in the hobby electronics world. However, one might not know that ARM processors are essentially in a lot of the hardware devices that are at the core of network infrastructure, wireless infrastructure, mobile devices, you know, every piece of hardware in your car, in your fridge, in your washing machine, wherever, right? And so this announcement kind of opens up the world of DevOps and all the advances and efficiencies that the traditional DevOps software development world has been gaining advantages in because of Docker and containers. It opens up this new hardware world to that. And one of the biggest gaps, as someone who has done some hardware hacking in the past, has worked on hardware projects at work, doing that loop of development and testing on hardware at the edge is probably the biggest gap in the market right now. And I think this announcement is kind of twofold. One is aimed at closing that gap, making it easier to develop on those hardware platforms. And then also, as ARM processors are going to the server market, making it so, just like Docker solves that problem for dev to ops, it solves that problem going from hardware to being able to write code, just normal software development code on the server space, right? And there's some joint announcements around AWS having dedicated ARM instances in EC2, and I think there's a lot of advantages there. And I'll leave some space for Mike to comment on it, but I have some follow up there as well. But love to
I mean,
discuss.
you basically took it all. Jeez, man.
Sorry.
No, but I mean,
we're leaving.
I mean, with back in reInvent, AWS announcing the ARM EC2 instances and everything, and you just see, okay, there's dramatic price reduction there too. I'll admit, I looked at it and like, all right, how can I take advantage of these to start saving some money on my servers and everything? And so now making this much easier and more importantly, officially supported means for building containers and everything. And I'm excited to see where it goes. I'll admit I haven't done a lot in the IoT space, but I definitely see how now it's going to be much more accessible to be able to write and, again, open up the DevOps pipelines and everything like Nirmal was talking about.
Yeah. And now we can start talking at these IoT conferences and ARM conferences. And, I think there's going to be an uptick, honestly, around the hardware side. And that's a world where I don't know if there's a lot of cross in between our industries, right? We have the typical distributed application developers, folks that are migrating legacy apps, trying to figure out the cloud future. There's other worlds out there: automotive, industrial, IoT, mobile, even the VR, AR, and gaming world, and they're at various stages of this DevOps journey. And I think this just opens up that world to the new way of doing things that the cloud world has kind of gotten accustomed to.
Yeah. I think us x86 people, which is essentially all the laptops. If you're on a laptop or a desktop machine, you're watching this on an Intel processor most likely, and we sort of have the spoils of all the features and all the great software. And ARM has traditionally been a place where it's because the processors are so tiny and they're focused on battery and efficiency that they haven't been number one, right? There hasn't been the place where all of that great stuff is. But I think for me, largely due to the smartphone decade that we've had, that has really changed a lot, because ARM has been around a while. They're not necessarily new. And in case you didn't know, ARM, for the audience, the company doesn't actually make a processor.
Yes.
I had to learn this recently. They're a licensing and consulting and expertise company, but they don't make the silicon themselves, which is a really interesting model. It's the opposite model of Intel. So I was watching yesterday after the announcement from Docker. I was watching there's a YouTube video on ARM from Azure. It's actually from Microsoft. So if you YouTube around, you can probably find that video. And it's one of the guys that helps build the data centers or is in charge of data centers talking about their data center designs. And the interesting position for him was it wasn't even about savings, like in terms of energy or whatever. For them, it was a matter of vendor choice that right now, if you think about it, all these data centers in the world, if they're running x86, they basically have two vendor choices, AMD and Intel, and that is their sort of the linchpin of their entire company to be able to build out these data centers. So for them, ARM allows them to then, I think Microsoft was saying they had at least 3 different chip manufacturers that they had partnered with to make ARM chips for their data centers. So now they look at this as like a diversity play of being able to have all the different options in case something happens at one vendor or one set of chips is delayed or something, that they can move something around. And for those of us that are on scripting languages like PHP, Node.js, Ruby, Perl, any of those sorts of things, from my point of view, if you're talking about cloud infrastructure, that stuff runs the same way on ARM that it runs on Intel, right? Nowadays, we just kind of do a Docker pull on those images, and those all just run. In fact, from my checking, all the official images I looked at all have ARM counterparts. In fact, let's just go take a look at that. Let's go look at the Node one real quick.
Yeah, I think what you're kind of pulling up on is that Docker has had the ability to run on ARM processors for a little while now. I think Justin was mentioning that. Justin Comek is mentioning that it's been like a couple of years where there have been ARM-based images. This announcement kind of makes it more production ready. There's a commitment there from both sides. And, there's still some issues there. It's not a first-class citizen yet, and now it is going to be. And there's past the kind of hello world kind of examples, you do get some gotchas. And the other part of this is, in my viewpoint, is when you're talking about these different hardware platforms, often you're also talking about chips that are communicating to other pieces of hardware that might be unique over USB, serial, some other interfaces, and interconnecting those into containers. It still can get a little tricky these days. And when you're talking about GPUs and serial connections and hardware level timing and robotics, more work still needs to be done on the Docker world to be able to support that. But this announcement is kind of an opening of, hey, we're taking this seriously, and yes, we're going to keep working on improving how Docker runs on these platforms, so it's even easier in the future to develop against custom hardware.
Yeah, and I'm excited too to see kind of how this folds in with orchestration and everything. I mean, imagine opening up a Docker EE environment and going to UCP and saying, all right, I want to deploy these containers across my IoT device fleet or whatever. So it'll be interesting to see where this evolves, where this goes in the future. But
yeah. A lot of this works today. I mean, that's what's the announcement. I think someone announced. You can tell, industry analysts aren't engineers usually, and so when they're putting titles up, I think it was TechCrunch. Docker developers can now build ARM containers on their desktops. That title actually would have been the same title like 3 years ago. You could have done that 3 years ago. Nothing has changed. I think Docker's basically their goal is to eventually make it easier, like you were saying, the path smoother from dev test to prod. But if you go into let's just look at the Node image, for example, there's this whole list of architectures where you can do Docker run Node on any of these platforms. We're talking old ARM, 32-bit ARM, the latest ARM v8, 32-bit x86, which is i386, PPC, which is, I don't know what's using that anymore. And then I think S390X is a mainframe chip.
Yeah. So actually, funny story, when DockerCon Copenhagen, so a year and a half ago now, kind of did a little hackathon with a couple of the other captains there. And I was playing around with making an alternative swarm visualizer, and we had it working with both the AMD 64 and ARM and on the S390X and Windows. And so produce one Node app that can run on 4 different architectures. And it was kind of fun to say, this app will run on both ARM and IBM mainframe. And I've never even touched a mainframe in my life.
Right.
And yet, they work on it. It's just,
what does it mean?
It's really cool.
What does it mean?
Yeah.
Yeah. Does TCP will still work on a mainframe? I don't know. Yeah. I know. It's, that's, I think, one of the big goals that I always got out of Docker early on was, not only making it easy to run any app the same way with the same commands, but they're also making any architecture able to run the same thing with the same commands. So the goal eventually, and it's not all complete, like the whole path, manifest files and all these different things, multi-arch is not all completely smoothed out, but we're really far, I think, down the road of you being able to build an app, it be on multiple processor architectures at the same time. It's one code base, and you store it in one repo on the internet, and you pull it based on your decisions. So then people think, well, multi-arch, why do I really care? I usually know what architecture I'm going to use. And sort of the example that I give is like, you might want some, like on a Node.js app, you might want some of that architecture to run in the cloud. And up until recently, if you're on AWS or Azure, you had to run it on x86. Like you did not have an ARM processor to run it on. So if you were going to test and CI and do all this sort of stuff on your code before you shipped it out to maybe your IoT devices, you didn't have a lot of choices for running it on raw bare metal ARM stuff, right? So it was nice to have all these images and be able to test them and then just basically change the from image to a different architecture, and then your code is built into a new image. That's kind of how I was talking about it. But now that we have like AWS's A1 instances, so if you weren't aware from Amazon's conference, the most recent one, AWS announced that they're making their own silicon, just like Microsoft, and they have these A1 instances that start with A1 mediums and work their way up. And what's crazy is like right out of the box, they have 10 gigabit. So $16 a month for a single AMD processor, but it's got 10 gigabit networking. So all I can think about is like, if I got network bandwidth things, like that's where I'm putting it, is on ARM.
And it's dramatically reduced in price compared to the x86 versions too. So
yeah.
I think that's where a lot of that lies. I think there's going to be cost advantages, power consumption advantages, bandwidth. It's also on a trend overall of, custom silicon and custom hardware, especially as we start to go into machine learning, AI. A lot of companies are going to start baking their algorithms and making their own hardware and their own silicon specialized toward very specific machine learning algorithms, specific type of applications, and developing against those has typically been a really big challenge. You have to make your own compilers. You have to make sure that your development environments are the same. I think these announcements are kind of the first baby steps toward opening up advances in not just CPU Intel x86 centric development across the board.
Yeah, it's gonna be what, I mean, ideally, a few years from now, we'll have the situation where, I mean, it's maybe already here for a lot of people, but for the us normal people, it's going to be this decision of let me test on a different architectures and let me see which one's the most energy efficient or cost effective for my performance that I have, and I'm just going to choose that. And it doesn't. It's an interesting world because for the longest time, in fact, one of the things I did want to bring up about this topic was the founder of Linux, Linus, a couple of months ago, when I think it was after the AWS announcement, he basically came out and was they're going to play a video, and I don't want to. Yeah. I thought it was a very interesting discussion that he was having, where he was basically saying, just because ARM exists doesn't mean that it's going to be like this major player. Let's all look back at the reason that x86 became so successful, and his argument was around everyone having this commodity hardware that was the same processor architecture type as in production, so that they could just play locally, test locally, then run it on a server somewhere. And that was one of the big secrets to the success, and that ARM doesn't have that yet. So when I read this, I think that this should be turned around now, and there should be someone needs to write a blog post that basically says Linus is right, and Docker and ARM together are going to be the most likely successful way we're going to solve this problem.
Yeah, and I don't know if it's the use case of like server side doesn't necessarily talk about power consumption or cost. We kind of, yes, to an extent, it's commoditized, but once you start going away from servers and you start to interact with devices and the cloud and multiple architectures and GPUs, that's a different story completely. Like, Linus is right about a specific area, which is kind of commodity software development and commodity applications. But the minute you start venturing off that farm, that territory, it's a little bit harder, and it's not there yet. And so, that being said, though, I think ARM is a lot in a lot of places, and we touch it every day. And does that mean that it's a good thing that it's hidden? Probably not. I mean, for every x86 chip, how many ARM chips are there, that are running? I don't know.
Right.
But I'm sure there's a multiplication there, or a multiple there.
Yeah.
So.
Yeah, I forgot how many they had an announcement, something about the billions of. How many billions of?
It was I hesitate to quote because I'd probably misquote, but it was something like from the start of ARM as a company till the 2000s somewhere, they made like 50 billion chips, and then the next 4 years they made 50 billion chips. So, and then the next like 3 years they made 50 billion chips or something like that. And so it's essentially almost, I want to say exponential, but it looks like an exponential amount of chips are being made.
And I don't think that's going to change anytime soon.
Yeah. No. And traditionally, those chips have been found in hardware devices, not necessarily on the server themselves, but, what's not a server these days,
Right.
Like,
right. I mean, yeah, to me, it means like if you're interested in doing something like let's say you want to make a custom, situation on ARM, like maybe you're not just a node programmer, but you're a low level programmer. Like traditionally you'd have to go get, you'd have to go get a Raspberry Pi and then figure out how to develop on that, or you'd have to buy an ARM laptop and then you'd have to deal with the limitations of that for development. So, yeah.
So I got these, like, I don't know if you can see that. I got these little development boards. I don't know. I don't think they are ARM. Maybe they are. I'm not sure. But there's a full stack server on this little thing. It's the same thing that's in the Amazon Dash button essentially.
Okay.
And it's got it's got FTP. It's got a web server. I mean, what's not a server? You know what I mean? My toaster eventually is going to have a server on it for no reason. You know what I mean?
Right. It probably already does. If you get one with like an LCD panel on it, it's probably got a little ARM chip just to power that. On their website, they say 130 billion chips, more than 130 billion. There's only 7 billion people on the planet, right? So more than 70% of the world's population are using ARM technology. Sensors to smartphones to supercomputers. Yeah. So I think it's really cool. I'm excited how easy it is. It's almost so easy that the demo is kind of like, okay, cool. I'm running ARM. So if you didn't know, you're on Docker Desktop. So if you're just running Docker Desktop, you can run ARM code right now. You can just either specify the platform in your Docker run command, or you can just specify the image that is ARM based, and it just runs. And it's using that because of QEMU. If you're not familiar with that, QEMU.org, it's a processor emulator essentially, but think of it like virtualization, the same way that it works the same way that virtualization does. And it just allows, it's been around a while, it's not a Docker thing. Docker just bundles it into Docker Desktop by default. And that's what we've been all talking about. So if you go on, what's crazy, if you go onto YouTube right now and you just search like Raspberry Pi Docker or ARM Docker or something like that, you'll find up to 5 years worth of videos of people demoing how all this stuff works. So one of the challenges with this announcement yesterday is it's here. Like surprise, you've had it for 5 years. It just works. Like you don't need to wait for the next release. You don't need to wait for DockerCon. What the announcement to me was really about was what we learned was like Docker EE is going to come to ARM, right? Like there's going to be official Docker support for the ARM. Instead of it just works, it'll be, well, you can actually call us for support with this kind of thing. The developer workflow experience is going to get better. Hopefully we'll have easier dealing with the multiple Arch images and all that stuff. And
who knows what will be announced at DockerCon next week too. I mean, there may be a whole new slew of tools and stuff coming. Who knows?
Yeah. Yeah. In fact, even just, if you think about it for a second, just Docker Compose in and of itself, being able to run Docker Compose up on my machine, and if I'm on Mac or Windows with Docker Desktop, what that means is I could have one of those services running containers in there be an ARM-based one, and then other ones that are x86, all in the same network, all talking to each other, testing apps locally on different architecture types seamlessly. Like it's kind of like, what a world do we live in kind of thing.
I think it's cool because it also opens up the world for things like unikernels, which have also traditionally been difficult to kind of work with, but have a lot of advantages. And I'm not a unikernel expert, but this is kind of along that path to getting to some more advanced ways of communicating with hardware, some more advanced kernels, more secure, right? So another thing that isn't really part of the announcement, but your Docker images come with the ability to be cryptographically signed. And a big challenge when you're talking about hardware is cryptographically signing what's running on hardware. And that becomes more and more important as we start to do more and more processing at the edge. And it's also the same things that we can do today on servers on a new processor architecture that might not have those advantages that x86 have from the DevOps world, but now do.
I mean, how much time goes by before we hear? I mean, or how often do we hear of these camera systems got hacked and all this kind of stuff?
Right.
All the time.
Yep.
All the time. I think I think it happens more than we realize. We hear a lot of news and we're like, yeah. But I think, there's a lot of devices. In fact, what's interesting is to see devices coming out now, like the Google Home, which specifically markets as not having a camera in it so that it can't be hacked, so that your privacy is protected by not having a camera in your living room or whatever. I just recently got a Google Home, and it's essentially a little tablet with a speaker built in that runs Android, and it has lots of things in it, but one thing it doesn't have is a camera. Because of that we've all been trained now that anything with a sensor or internet access in my house is potentially hackable. And you're right, Docker, I mean, to me, it's like if the app gets hacked, the OS can still replace that container much easier than you would have to flash the firmware on a device to get rid of the hack, right? So the whole remediation seems a lot easier to me, assuming that they didn't break out of the container and all that. Obviously, there's always those risks. But, well, okay, so we've been talking about this a while. Let's get some questions and see what's going on in chat. Thank you so much to those people in chat that have been around for the last 40 minutes, anxiously waiting for us to read their question and hopefully have an answer. So feel free to cherry pick if you guys want to just cherry pick any good questions you want to answer. If you see anything. Thank you, everyone who's talking about the course. I appreciate the Docker course love.
So Jose Aponte, not sure if I'm pronouncing his name okay. He's asking about moving a Docker container from dev to production. How does that work? Well, because you use Docker, that is one of the easiest things to do. The command that you wrote, run, so if you do Docker compose up D and have a production YAML that points to the same container that's production ready, that's correct. You've essentially productionized your container. And that's the advantage of using Docker in a nutshell. You've basically, because you're using Docker, that is a very easy thing to do. And so, Jose, that is an okay command to run.
Absolutely. Yeah, and eventually you'll want to start looking at orchestration using Swarm or something like that to better support your apps in production. But if you're just getting started, starting off with a Docker Compose up and going from there, that's certainly a good first step towards that. Because once you step in the orchestration world, there's obviously more to learn and that kind of stuff. But again, like Nirm said, it's starting with this container and you build it locally and you can push it to the registry and just run it from there.
Yep. All right.
Biker's back. Sorry, what, you done?
Yeah, go for it.
Biker's back. He is very consistently on every show. He's one of the Docker Mastery students, hangs out in chat. Says, I need to handle TLS and containers because I have to insert HSTS in response headers and Docker Enterprise Interlock Proxy won't do that. Where do I do HTTP to HTTPS redirect in the containers nginx.conf ? And he goes on to say, inside the container, I don't have the domain name, so not sure how to rewrite that. And then do I put both 80 and 443 in the container nginx.conf and rewrite HTTP to HTTPS? And then he gives us a rewrite rule. He's throwing in code in the YouTube chat. That is probably not they probably didn't plan for that when they made the YouTube chat.
When the comment came up, it flagged it like, "Hey, do you want to show this or not?" I was like, "Yeah, let's."
Yes. Put some regex in your system. There's no harm to that. There's no harm.
Yes.
Well, that's a great question, Biker. I don't have a direct answer for you. I don't know if either one of you experienced or dealt with HSTS in containers.
Yeah, I mean, at the end of the day, HSTS is just headers to kind of force HTTPS to occur, and so so yeah, there's a redirect, there's including those header responses and everything. If you're running your containers just directly as Nginx, and that's where you want your TLS negotiation to occur and everything, then yeah, that makes sense. So having a config file there that's injected with an environment variable or something like that to kind of say this is the host that I'm serving, because yeah, the container image, you probably don't want to bake the image with that host name. You want to be able to reuse that container for your staging environment, your production environment, wherever. And so whether you want to use that as an environment variable or you have a kind of a startup script that builds that config file, whatever makes sense to you. That's typically how we've done it. But.
Yeah. Whenever I have TLS issues like that, usually that, when you start to do the container worlds, you start to go into the world of containers, it's proxies all the way down. Have you ever heard turtles all the way down? Right? It's proxies everywhere. Yep. So I would say you might need to, you can go into the containers Nginx configuration and manipulate headers there. And if that's not working for you, then I would suggest putting another proxy or set of proxies in front of your Docker EE network, either and configured in some kind of automation script with the right way to terminate TLS. Just like Mike said, figure out where in your architecture you want to terminate your TLS. And typically, because of other systems that you can put in place, you don't necessarily need to terminate TLS all the way at the last container that responds to the traffic. Right. You can, and it also varies on the degree of masochism that you enjoy. But you can move that TLS termination point a little bit more further away from the actual endpoint, and you can then also establish internal mutual TLS that's its own separate PKI infrastructure that comes out of the box with Docker EE and Docker that can help you ensure that there's encryption of traffic internally if that's a concern. But typically public facing TLS termination is done kind of before it hits the majority of your infrastructure. And that's kind of the pattern that most of us follow. Is that right, Mike and Bret?
Yeah, and I mean, I actually see a comment in here. It was mentioned previously you're a big proponent of traffic, and yes, I am. So actually, in a lot of our clusters, we kind of have the traffic service. I'm going to do some kind of hand boxes here, but we have traffic as being our 80 and 443 entry points, and then from there, wherever it's going is based on the traffic routing rules. And so in this case, Nginx would just be another container that's configured to receive traffic from traffic. And so then the TLS termination is actually happening at that traffic's reverse proxy. So it has your SSL certs and everything else that you need. And then internally, whether you're doing mutual TLS or just self-signed search or whatever it is that you need to do, that's obviously up to your organizational needs there.
Yeah.
Hey, Bret. Can we take a quick pause from the questions and talk about what we're all doing at DockerCon?
Let's do it.
So, Bret, what are you doing at DockerCon?
For this, I'm wearing my hat.
Oh, there we go. My hats I can't reach them. We should have planned ahead of time. Let's see. I'm doing a workshop on Swarm 2 different days. So when you registered, you can sign up for workshops. I think they're like $100. And I'm doing a Swarm workshop on Tuesday and Wednesday. On Tuesday, I'm hosting a media panel. So some of the people from those places that I was just showing headlines, I will be talking with, and basically we'll have a panel of people in a session where I, what do you call it? I mediate, host, whatever you want to do.
Moderate.
Moderate. Thank you. Not mediate. I'm like, it's going to be a fight. Container fight. Go. And so I'm doing that on Tuesday, and then on Wednesday I'm speaking on Docker. I think it's awesome. Docker for Node.js rocks for devs and ops. I'm trying to remember the title exactly, but basically it's Node.js. It's my course crammed into 30 minutes. Talking talking about basically to anyone who's interested in Node.js or is doing Node.js today to make sure that they're using all the best features of Docker specifically for how Node.js would do it. So that's going to be Wednesday. And then Thursday, if depending on how well the session goes, we all if you're used to DockerCon, you know that all the votes for the best sessions get replayed on Thursday. So so session hosts or session not instructors, presenters are volunteered by Docker to do their session again on the last day of Docker. So that the cool thing is if you're at DockerCon and you couldn't get to all the things on Tuesday and Wednesday, that on Thursday the top 10 or top 15 or whatever will show back up again, and you'll get a second chance to watch them give their talk. So depending on how Tuesday and Wednesday goes, I might be doing that on Thursday. How about you?
Go ahead, Mike.
All right. I'm just because I see it in the comments, I'm most excited to see Ashlyn. So it's good to catch up with everybody.
It's been a while.
Monday, yeah, we've got a bunch of different things going on. So I'm actually doing just like I'm doing a talk and a workshop. So my talk is going to be Tuesday, not in the first speaking slot right after the general session, but in kind of in the second slot. I'm doing a getting started with containers. There's a lot of people that are coming that like, what are these containers? What's working? What's the buzz? All that kind of stuff. So we're gonna explain it all. And of course, we can only get so deep with the breadth of technology there is and everything. So hopefully it's a good primer for the rest of the conference for those that may be new. So definitely come out and check it out. And then I'm doing a workshop both Tuesday and Wednesday afternoon, evening timeframes with Docker apps. So I was on the show a couple weeks ago talking Docker app and whatnot. And so we're doing a workshop. I've been collaborating with the Docker app team and talking about all the new stuff that's coming in, CNAB support and all that kind of stuff too. And it's going to be fun. We've got some fun demos, fun things that we're going to build, and I'm excited for it. I just need to finish all the write-ups for it. So
get your presentations done.
Got to finish our presentation before we can give them.
Right.
What Michael's talking about, in case you didn't get to see the show like about a month ago, Michael and I were on the show on, if you go to my YouTube channel, in case you're on the Docker channel, that's bretfisher.com/YouTube. Just search for Michael there, and you'll find, or I think Docker app. Maybe you can search for that. And he talks. He has this whole great demo about what Docker app is. It's a new command line utility from Docker that helps solve more problems with your container apps. And we won't go into it today, but if you're interested in that, go check that out. The underlying technology or standard around that is called CNAB, C-N-A-B. And DockerCon has sessions all about that. In case you're going to DockerCon, you can definitely get that stuff. Nirmal, what are you doing at Docker? Oh, sorry.
I was just going to say, and if you're there too, look me up too. I'm doing a couple of hallway tracks as well too. And if anybody has questions.
Yep.
Yeah, cool.
I just did a container native application bundle CNAB presentation at our local Triangle DevOps meetup in the Raleigh-Durham area. So if you want to know more about that, check that talk out as well.
You did it for the DevOps meetup, but not your Docker meetup. So
I know. It's the same group. It's the same.
I know, it's all good.
Is it? Yeah, it's.
Have to keep poking you. So.
I know. Thanks for holding my feet to the fire. So
keeping it real, keeping it 100.
I'm actually not speaking at this DockerCon, which is nice because I've spoken at a lot of conferences, and when you speak at a conference, you don't really get to enjoy the conference. And so this time I'm essentially looking forward to hanging out with my extended family, which is all of the captains, all of my Docker friends, all the new people that are new to the Docker community, all the community leaders, and also, seeing what's new, finding out what's new. I work in emerging technology at Booz, and so I'm always on the hunt for what that next step is and what people are getting excited about and helping folks out. So I'll probably be helping with the hallway tracks and just going around and answering questions and hanging out with all the people that I love from the Docker community. So
awesome.
I get to thoroughly enjoy it and not be a nervous wreck before my presentation slot, which is always the case at other conferences. So
yeah. You have to tell us how it is. You have to say let us know later how DockerCon was, because we'll be there, but it's a blur.
And he'll show up to our talks and ask us all the hard questions afterwards too.
Yeah, yes, I'll sit in all your sessions and yeah, yep.
Yeah, sit up
like
front.
Some of these questions. Shall we go back to some of these questions we have? Do we still have some time, Bret?
Yeah, absolutely. We've got plenty of time. What I would like for you to do is to be in my session, and then Michael's going to rogue show up with a dyno.
Do you want me to?
Well, no, not really, but it would still be funny.
We can make this happen.
If it was rehearsed, it would be funny. If it was random, it would be like this thing where, you know how you get in like tunnel vision when you're on stage and like something takes you out of it. Like I was gonna say, Nirmal could just sit in the front row and like rage walk out halfway through, like throw up his arms and be like, bah, walk out like that. You know, we'll just be like guerrilla sessions where we're just like trying to wreck each other's flow, because you get on stage and you get in this flow.
I would never do that to you, Bret or Mike.
Well, I think it's hard too. I mean, with the lighting normally, you can't see the audience.
You can't.
So it's,
yeah, you can see like the front row. You can tell if someone's in the front row. That's why I'm saying yes to like stand up and walk out in the front.
I'll wear the dino suit and come and eat NERM or something.
Yeah. You'll get the sound guy back to give you a mic, and you'll just sit there smacking your lips with your sandwich. Oh my goodness, there's so much good trolling we could have at DockerCon. But the nice thing is it's a great group of people, and we take it very seriously. We know how big a deal it is to stand in front of 600 people and talk. So we all respect each other, and those kind of shenanigans don't normally happen, but maybe someday. So let's get back to some questions. Josh asks, my company wants an internal server with Swarm, bare metal, with GitLab and container registry to start. How can I go about persistent storage other than volumes? So it's an interesting question, because the answer is volumes, but maybe not in the way you're thinking. Because if you think of the standard volumes command, if you're not aware that, like all the other objects in Docker, they have those options on them, and volumes have drivers. And whether you're in Docker or Swarm or in Kubernetes, there's essentially a driver ecosystem that allows you to connect to different types of storage as if it was connected to your container natively. And that just depends on the storage, right? Whether it's like EBS storage that's connected to your AWS instance, or it's DigitalOcean block storage, or maybe you're in your data center and you have NetApp and you need NetApp iSCSI. Like all these things have drivers essentially to get your container, and that's technically still volumes. It just requires a little extra piece of software, and that's different depending on your setup. So really the answer is, okay, well, what storage do you need to use, and then how what orchestration or how are you running your containers, and let's see if we can't take those two things and get them connected in a way that makes sense. And that's usually the way you would solve that. So the answer is yes, volumes, but also drivers.
And I'll throw in there too, so with like GitLab and their container registry, it's got options to actually store the blobs for each of the layers in the container registry on like S3 or other offerings. So you can certainly look at those options there as well.
Yeah. Yeah, those are all there, and like you can, even if you used Docker registry and you wanted to do, whether it's the open source registry or Docker EE, there's also S3 stuff for that, so that you can store your images in there. Yeah, so it's all there. It's still in volumes. It's just not built into the Docker engine out of the box, so you won't see that option. It's all about adding in plugins. If you actually go to the Docker Hub website, and you'll find in there under like the Discover tab, you can actually click on plugins, and you can go and check out some of the volume drivers that Docker has certified. If you're going to do Kubernetes, that would be over on the Kubernetes site. You can find more information there. Of course, Google is your friend. But that's a great question.
Yep. And often a source of confusion.
Yes.
Indeed.
All right.
Similar to networking drivers, right? Like in all of the things, Docker and Kubernetes, there's networking options. The things that come out of the box aren't necessarily the ones you should always use. So, these tools are helping us solve these problems, but they don't do it all by themselves. They need help from the ecosystem. So if you're doing networking, whether it's Docker, Swarm, or Kubernetes, you also need to worry about drivers and plugins and other tools to do that. So,
yep. I'm just trying to look through these questions. Let's see. Have you two found any?
Let's see. I got one.
I'll respond to Palantir since it was kind of made. So as I mentioned previously, you're a big proponent of Traefik. Yep. Are you planning on doing a course on that in Docker? I'm not currently planning on that because I don't have the bandwidth to do it. Traefik, I know, is doing quite a bit. They've hired some extra developer advocates and that kind of stuff too. So I imagine that we'll see more hands-on examples, tutorials, that kind of stuff coming from them before too long. But
yeah.
maybe I'll team up with Bret one day.
Traefik, I used it at a hackathon last year, and it's pretty straightforward to get hooked into Swarm, but it can get a little tricky knowing what the labels were. And Mike, you actually helped me figure out what the right labels for the containers.
Yeah, the tricky part is getting through the documentation and everything.
Yeah.
But once that works, it works, and it's seamless.
Yeah,
it's kind of like other things like Nginx. It's like the configuration is the hard part. Once you got the config working, it works pretty reliably. In case you're focused on Swarm or just Docker Compose or something like that, I'd say go to dogversus.cat. That's actually my GitHub repo for Swarm examples. I'll throw that in. That was in my YouTube chat, right?
Did you put that in there?
Yeah, I'll put that in. I'll put that in the other chat too. So dog versus cat is me using the Docker's sample voting app and just sort of turning it up a notch with a whole bunch of examples in YAML. And one of them is one of my favorites actually, is the Traefik one. And so if I go here to the Stack Proxy Global, I've got what I consider, unless you want to use Traefik Enterprise, their new offering that does probably a lot of this out of the box without having to manually do all this stuff. It's got a lot of sweet stuff in it, including a Traefik init. So basically, there's the Traefik binaries that you want to run in the front of your containers that are sitting at the edge of your environment. And then you have sort of the database and the backend stuff that's making the decisions. And so this stack file for Swarm breaks all that out. And it doesn't even require a config file for Traefik. It does all the config. And this is one of my favorite things of Traefik, is that it allows you to do all the config sort of fileless by just throwing in command line options for everything you want to do, which is extra effort on their part to support both kinds of development, because you can use their TOML file, I believe, to do the same thing. But what's for us is great is that we don't need to then store a config and have something. We can just look at the Docker command that's run, and that shows us the whole config. The other things in this file that I'll just talk about for a second is that because it's highly available, it has a console backend. Unfortunately, right now, the console backend is not HA, but it allows you to have multiple Traefik front ends that all agree on their configuration from a backend storage, as well as we are protecting the Docker socket. So if you're familiar with these sort of tools, when you start talking about orchestration, you need to worry about those tools, especially proxies, being able to talk to your orchestrator. So whether it's Swarm or Kubernetes, they need to be able to talk to those APIs to get the information about your containers. Because the last thing you want to do is update your proxy manually every single time you launch a new container that needs a web URL, right? That's not the way to do it. You definitely want a tool that can understand your orchestrator, right? We all have more important things to do than that. So on this one, it's using a small little library essentially that's protecting the Docker socket and giving it read-only access to Traefik, so Traefik doesn't have too much access to it, and it uses the network for that. It's a pretty neat. I didn't make it up. I just put it in this file and made it work. So it's a pretty neat way, I think, to increase the security on your setup so that the Traefik front ends can be off of your managers, which is important to keep them in sort of the DMZ, and then have the things with the full permissions in the back. But you don't even need write permissions. You really just need read permissions for Traefik. So that's pretty good back there. And then down at the bottom, I have all the networking configurations and the volumes necessary to make all that work. So I worked long and hard on that one. So check that out.
So yes, we should make a course.
Awesome. I'm gonna have to check that out, Bret.
Yeah, it honestly, it just works. If you're curious about the way that makes like another app work, so if I just go into a different stack file, this one's for Ghost. The only thing I have to do is to throw in a couple of labels. Basically two. What port is the container running on, and what URL am I responding to? And then Traefik picks that up automatically and then can route that traffic. And so for it's a really great demo setup because you can shoot a DNS wildcard to a single swarm host, and then just keep up making new names in compose files and throwing up stacks, and suddenly those websites just work. Like you don't have to change DNS, you don't have to do anything other than just do Docker stack deploy.
I do exactly that for my machine at home. I've got a wildcard DNS pointing to it, and then I just use Let's Encrypt to provision SSL certs.
Oh yeah, and Let's Encrypt. Like, and it comes with Let's Encrypt. Like that to me, this is the new standard of proxies. Like now I look at proxies and go, well, can it do Let's Encrypt automatically? Because if not, I'm not sure I'm interested.
I don't know if that's as important in the enterprise world, though.
This is true. This is true, right? But I mean, if like someone was talking to me this the other day. So I former life, I used to do. I had a job where I was working for the city government, and I got hired to do PKI on Windows. So I was essentially building out the certificate platform for a 7,000 node enterprise, and that's where I got my teeth. I cut my teeth on PKI for that job. And little secret is they hired me for it when I knew what I was talking about, but I didn't have a lot of experience, but they hired me anyway. And they did not regret it. Luckily, I did not get let go from that job. But the PKI infrastructure all has web APIs. So I'm just like, I want someone to make, the next thing is obviously we have open certificate stuff, but Microsoft is a big enterprise deal when it comes to PKI. And when you set it up really well, it's kind of works awesome in your environments. They have a web interface where you can get certificates, and I'm sure Nirmal's played with this stuff. Mm-hmm. But that has an API built in, so it would be really cool for someone to have like a Traefik plugin that will do the same thing that Let's Encrypt does, but does it against Microsoft PKI. That's on my wish list, because we need that level of ease in the enterprise. Like if this app is coming from the right host and the right permissions, give it a certificate from the internal enterprise. Basically follow the same rules as Let's Encrypt, because obviously most enterprise apps, like you're saying, are not publicly facing, so they can't. That's one of the requirements of Let's Encrypt is it has to be able to validate that your app is real and the DNS is real. Can't really do that in a data center most of the time.
So, I think a lot of the questions, and this is kind of universal, especially as community leaders and doing a lot of meetups and training, and maybe you don't see this, but the top questions I see are domain name related, TLS related, and certificate related, and maybe NTP sometimes when your timing's off, because that affects the first two. And Docker solves a lot of problems, but it doesn't solve your domain name issues or your TLS issues. And in fact, it forces, I think in the past, and this is from doing a lot of legacy and enterprise work, you can kind of shortcut doing the domain name stuff and the TLS stuff by just hiding behind the network operations team setup and hiding behind a firewall, and it's not your problem anymore. When you start to work in the world of distributed applications and containers, it becomes you can't shortcut it anymore. You're forced to deal with it. And I think that's where a lot of the problems and issues come from, where we are very used to kind of like, oh, we'll fill in the certificate later, or we'll fill in the domain name later and do all that stuff later. But you actually need active DNS working. You actually have to have some kind of PKI system up and running, and have valid certificates. Otherwise, like I said, the container world and distributed application world's all proxies, and proxies rely on those two things working well.
Right.
And you can't man in the middle. It's very hard to debug certificate issues because it's designed to not be man in the middle,
right?
And to be debugged. And so your traditional kind of mental way of thinking about debugging it doesn't work the same way. And I think a lot of these questions we're seeing here about headers and IP addresses in containers and HSTS and certificates, it's all because you have to there's proxies in between the traffic as it's coming in and the actual container. And the containers by default are kind of on a port basis. They're not associated directly with an IP address in the sense that like a virtual machine might have, or a server might have. And so, the part of the network stack that you care about it might not all be there in that same way that you're used to in a traditional enterprise, if that makes any sense.
Yeah. Well, I think this is also this is great. This is it's a little bit of a tangent, but this is indicative to me of the fact that this shows that Docker is maturing because we're dealing with these enterprise issues. A lot of this stuff the cloud solves for us, right? Like apps are predominantly open to the internet in a lot of ways. At least web apps are. So Let's Encrypt will work. NTP is solved by the cloud provider in most cases. Like a lot of these things have been worked out. There's automated certificate providers on these clouds now. I'm just going to humble brag here for a second. I have a post from 15 years ago on my old website, Fishbrains. In case you've followed me a while, I have an old website, 20 years old now, that I would blog about Windows forever, and I just kind of moved. I left it there as an internet archives kind of situation. But I have this really long, detailed article on the Windows NTP. It's actually such an old article that the HTML codes are broken in it because I've moved it from blog engine to blog engine to blog engine. But I kept it up because it's one of my most popular posts from 15 years ago about setting reliable time sources, dealing with time sync and virtualization. It just goes on and on and on because I was dealing with it. I mean, I'm linking to a Word doc on Windows 2000's website. Like that's how old that document is. And awesome. And I would say 90% of it is still true today. Like time hasn't changed. The way we deal with time on the internet hasn't changed. We have SNMP now, or SNTP now, a little bit simple. But the base protocols for this stuff. And if you've ever dealt with time, it sucks. I mean, Docker is not without its situations dealing with time and resolving time in containers versus host versus the physical host. And
if your time is off, if your names can't resolve, and if your certificates aren't valid and trusted, nothing works. And
you're not going home for the day. You're staying at work.
And those three things, plus maybe like an actual network connection, like assuming the network connection is up, you can't assume those three things away. And it's kind of an 80-20 thing. I think those three things kind of are the source of 80% of the issues. And then maybe you get into storage and other things. But there's another question here, maybe kind of getting away from this topic. Multiple workloads, one being more CPU intensive. So this is Jonathan Detroit, or Detroyer. Sorry for about the pronunciation. And a stateless app. Tips on running two different workload types in one cluster, and when do you decide to use a second cluster? I'll have a shortcut answer. It depends on your budget. But
consulting answer depends.
That's a kind of excuse answer. What's the default Swarm or Kubernetes container scheduling algorithm?
It's kind of spread.
Yeah,
it's kind of like random, right? Or is it bin packing?
It's spread.
It's spread.
Spread meaning that it will intentionally spread. Right, the workloads will intentionally go on a different node if there's too many workloads on one node.
Yes,
I think that's at a per service level, not across all services.
Yeah.
So if you have like 3 machines, 3 replicas, it'll try to spread those 3 replicas, but not necessarily it's going to spread across services.
Yeah. Too. And the classic consulting answer to this would be, it depends. And that would be your CPU intensive load. If it's long, I would say it depends on how long running those containers are. And if you have a container that's CPU intensive, that's just one container that's long running, it might make sense to just allocate a certain part of your cluster for that specific workload and make sure that your other apps are not on that they don't get deployed. Now, not knowing if you're on Swarm or Kubernetes, that does make a little bit of a difference here, but you might not need a second cluster because one cluster means that you have multiple machines that can take that work. And I wouldn't futz around with the default scheduling unless you really need to and you see some weirdness there, because I think over the long run, it's kind of hard to be more efficient than random at times. And you might have some more knowledge that you can label that container with. So if you know it's long running, if you know when it's going to be most resource intensive, when those events that trigger that workload are happening. That's more information that you might be able to script or do some automation and label those containers to be more efficient based on that additional information. But if it's kind of, a bell curve distribution or a Bayesian distribution for that, I would just let it be and see how that compares to trying to optimize it too early.
Yeah, and kind of to add on to that
Yep.
too. I mean, I'll talk swarm world, and it's still kind of analogous too. So like Nirmal was saying, you can have a couple nodes that are labeled in such a way to kind of say, okay, these nodes are maybe CPU intensive nodes. For example, if I'm running AWS, okay, these are T3 families, these are my C families, whatever. And for a CPU intensive workload, you can set the placement constraints to say, all right, this workload can only run on the CPU, the instance family that's better supported for CPU intensive workloads. And then I could just put the stateless app that may be more burstable on a T3 workload, for example. And so you can use placement constraints to help kind of game that system a little bit. For us, a lot of times the decision to go to a second cluster is usually more on RBAC needs than workload needs. If I want different administrators for different ones, or I want to change things up. Of course, if you're using Docker E, there are ways to work with that even in a single cluster. But if you're using Community Edition and it's like, okay, I want this team to be able to deploy their services, but they can't touch these other services, then that would be a good reason to go with a second cluster.
Yeah. To me, I mean, we're going to all weigh in on this, but I think we're all saying the same thing. To me, it's one cluster until you can't. I mean, the whole goal to me of orchestration is that we're reducing the management overhead of managing individual nodes. And if you start breaking the clusters out, all the clusters have various technologies and tools to help you isolate workloads in places you need them to be. If you need it in a DMZ, or and so that all exists depending on whether you're using ECS or you're using Azure, or you're using whatever your tool is, Kubernetes, Swarm, you name it. If it's a product that's designed to have multiple physical servers, multiple OSs in the same cluster, then it's got a way for you to control those apps so that you can, if you're concerned, whereas you don't want to have the CPU and the static ones on the same server, then you can easily do that in various ways. They all have a slightly different way of doing it. They have different terminology for how you do it, but they all can do it. And I mean, most people don't even realize that you can do a lot in one cluster. And most people think, oh, well, doesn't that put all my eggs in one basket? And I don't really see it like that. That's like saying, that's why you have multiple servers, right? You're increasing all the different redundancy layers. You've got all this different stuff. And the things that operate a cluster, they can break in most cases. They can break in ways that will still let your apps keep running and your servers are fine. You just can't necessarily continue to operate the cluster until you fix those broken things. So it doesn't mean that you're putting all of your application eggs in one basket in my mind. It just means you're simplifying the management overhead. And so if you start creating arbitrary clusters, like, maybe you have a dev test cluster and a production cluster, and the reason for that maybe isn't what you're thinking, because as an ops person, what I always want is my ops team to be able to screw up on clusters before they screw up in production. Because developers get dev and test to test and dev all day long, and they make all kinds of mistakes to learn and fix their stuff. But operators often don't get sort of a real world setup that someone would care about if it broke in order for them to make mistakes early. And so if they only have a production cluster, they're going to make their mistakes and learnings in production, because often, if it's a production-y like system, it's got to be a little bit different. And so I'm always advocating for, if you're a real shop with like real money businesses running on this stuff, no matter what cluster technology you're using, have two clusters, not because you need that kind of isolation, but have two so that you can learn and do some real world stuff on one that's like dev test, staging, whatever you want to call it, pre-production, and then have that real production cluster so that you can learn without breaking bad things.
Yep.
Anyway, that's my advice.
Yep.
It's free today. So,
what they say about free advice?
What do they say?
It's worth every penny.
Well, then us talking on YouTube is worth a whole lot right now. You're getting the best bang for the buck right now.
That's
Internet. All right. Any other? I think we're out of questions, so we're going to give you one last shot to get questions in before we wrap this up. Before we always have like one last good question that someone asked, but before we do that, Michael, where can people find you on the internet?
All right, you can find me pretty much anywhere with the name MikeSir87, MikeSir87. Twitter, GitHub, everything. And a lot of people ask, where does that name come from? So Michael. Okay, S is my middle initial, and it's actually Scott. So when the office was really big, Michael Scott, I got that a lot too. So, and then Irwin IR. So when I was 12 and made my first Hotmail email address, I was like, Mike, sir, that sounds so cool, 87. And so it's just kind of stuck.
And you stuck with it. Good commitment.
You call me Sir Mike, and I'm like, sorry, that's.
I'm impressed with your commitment over your lifetime.
That's right. So that's me.
How about you, Nirmal?
You can find me at normal faults. I basically everywhere except for LinkedIn, and I think the LinkedIn address is somewhere in there. But my main kind of page, I promise to put this up sometime this year. Will be at nirmal.io. There's nothing there right now, but normal faults is kind of where you can find me on the Twitters, on the GitHubs, Docker, wherever.
We've got 2 promises and commitments in a single episode.
I know. I gotta. I'm really holding myself up to this.
Yeah. Does anyone ever say Nirmal faults? Because that would have been a fun.
I think most people's phones will autocorrect me to normal anyway. So I'm just embracing
that's a great bonus feature. Is that phones already know my handles on the internet because they can't spell my name.
Yeah.
All right. So I think we're out of questions. I don't know what Thomas is saying. He's asking when the stream starts, but it's been started, so I'm not sure what we're talking about over there. We've been talking for an hour and 20 minutes. So I want to thank my guests so much for being here, taking time out of their day. We're days away from flying out to San Francisco for DockerCon, so I'm sure they're super busy, but they're here anyway. Do check out, if you're thinking last minute, by the way, we have a DockerCon coupon. If you've hung out because you're ready to go to DockerCon and convinced that we're the people you want to high five and get a selfie with, you can use YouTube as your coupon. I think you get 20% off for that on your DockerCon registration. And do that. That will make Ashlyn happy. She's on the chat today, I see. And we'll want to see you there. And definitely, if you're going to be at DockerCon, you must come see us all. We're going to be around the conference all week, as you probably have heard us talking about. So come and give us a high five. Tell us what you're doing with containers, and then get a selfie list on the internet. We always love Docker selfies. If you see a dyno, someone running around in a Tyrannosaurus Rex kind of costume. Yeah, if you see someone with little arms and a very large melon, that might be Michael or it might be someone else. But 50, I don't know. Do you have a team this week? Are you?
I've got 2 suits. I haven't figured out. Nobody's willing to be conned into taking the second suit.
So
yet.
Michael is looking for volunteers. Any of you on the chat? If you're thinking you want to run around in a dino costume, find Michael at DockerCon. He is looking for a partner in crime. Little hands partner. Running around.
That's right. Waddle everywhere.
So that'll be fun. In case you are on the chat and we didn't get to your questions, we'll do one last scan after we go dark. I don't know what you would call it. After the show is over, we will still talk in chat. That's how YouTube can work. You can still talk in chat after the video. Just don't leave the page. And we will answer any of those questions after. Again, I just want to mention, if you get any of my Docker resources, check them out at bretfisher.com/Docker, including my new Node course that just launched today, so you can be one of the first in there to hang out and have fun learning the best of Node.js with Docker. And again, thanks so much to Michael and Nirmal for being here. I will see you all in a few days in San Francisco, and we will be live here next week. I don't actually know what day yet or time, but we'll put up the announcement on YouTube. So if you're on YouTube, make sure you're on the Docker channel or my channel or both, and subscribe and click the little dinner bell, because that'll let you know when we're going to be live. It'll sort of ping up on your mobile device when we're going live. We'll be here live next week with some other awesome Docker captains, and I'll see you next time on the internet.
See ya.